Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am going to discuss today is Cocomo model and the subject code is BMC 302. The subject under which it is covered is software engineering and it is for third semester second year students. So let's understand what Cocomo model is or what Cocomo is. It is basically a constructive cost model and is one of the most widely used software estimation model that are being existing nowadays. And it was developed by Barry Boehm in 1981, but it is widely used till now. So the usage of Cocomo model is basically that it predicts the effort and the schedule for the software product development, which is based on the different inputs which are related to the size of the software. And it also talks about many cost drivers that affect the productivity. That is because whenever we are estimating the cost of any of the software, in that case, the cost basically depends upon the size of the software and the different cost drivers or the different type of costs that would be incurred when a particular software is being developed. So it predicts the effort because it is a cost model. So it predicts the effort that would be required in order to develop a software and how much time it will take up so that that particular software gets completed in time. So we have Cocomo that is applied to three of the types that are the coefficients. The first one is the organic mode and the last one is the embedded mode. So let's understand what organic semi-detached mode is. So when we talk about the organic mode, it is a development project which can be considered as an organic type is of the type if the project deals with developing a well understood application program, the size of the development team is reasonably small and the team members are experienced in developing similar type of projects. So here basically in the organic mode, we talk about developing a software which is clearly understood by the developers. The developers also have the knowledge in order to so that they can develop similar type of projects, and also the size of the development team is small. It is not that we are developing very large projects when we are working with the organic mode. So organic mode talks about the size of the development team to be small, number one. The application programs are clearly defined or they are clearly understood. And number three, the team members are experienced who are developing the similar type of projects. The next one that we have is semi-detached. In the semi-detached type, if the development consists of a mixture of the experienced and the inexperienced staff, then the team members may have limited experience on related systems but may be unfamiliar with some aspects of the system being developed. So when we talked about the organic system, in the organic system we had three things, that is the development size is small, the team size is small, then the team members were experienced. But when we talk about semi-detached, here we have a team of the experienced and the inexperienced staff. That is the major difference between the organic and the semi-detached mode. The team members, there might be some of the team members who do not have any experience on that particular project on which they are working or they are working for the first time. And the other team could be the set of experienced people who help those inexperienced people to work with the software and develop a software. So here the productivity of the people or the development team gets lower down. Plus, the application program might not be well understood by the team and hence the cost could be more as compared to the organic mode. The last one is the embedded. A development project is considered to be of embedded type if the software being developed is strongly coupled to the complex hardware or if the stringent regulations on the operational procedure exist. So when we talked about and semi-detached, we were basically working on the application programs. We were not talking about the inclusion of the hardware into it. But when we are talking about the embedded softwares or the embedded projects, as the name suggests, it talks about the embedment of the software and the hardware. So here the software is developed along with the hardware part. So it is strongly coupled to the complex hardware, and there are some of the rules and the regulations that also needs to be taken care of while we are working on the embedded one. So if we look over here, embedded one is mainly the more complex software development, where we have the inclusion of the hardware as well as some of the regulations. Also, if we talk about the semi-detached, the cost would be more as compared to the organic one, because here we have a mixture of the experienced and inexperienced personnel. So the inclusion of inexperienced personnel reduces the working or the efficiency of the staff. If we talk about organic, it is basically talking about the team size to be small, but whatever people we are using in the team, they are all experienced in developing the similar type of projects. Also, the application that is to be developed is well understood. So if we look into the comparison, the first one is the organic mode, where we were saying that the project size is small because the team is also of a small size. So here the project size is typically 2 to 50,000 line of code. LOC talks about the line of code, K talks about 1000. So it is 2000 to 50,000 lines of code. The nature of the project, it is just a summary where we talked about that it is a small size project where the experienced developers are developing it in a familiar environment because they have already worked on such kind of projects before. For example, the payroll, the inventory projects, or maybe the library management system, or it could be the bank management system. These all are the type of the organic softwares, or the softwares which are taking the organic mode. Here, because they are already experienced, they have already worked upon it, so the innovation is very little. They are not talking about anything new feature added to it. Innovation could be like you are trying to change for the betterment, but here they do not apply their own minds. They just try to build the code as given to them. And the deadline is also not tight because it is a very small project which gets completed in time normally, and the people are already working on such kind of projects for a very long time. And the development environment is familiar and in-house. The the developers know how everything needs to be done, and hence the development of the software is easy in the organic mode. Coming to the semi-detached mode, here the lines of code are basically 50,000 to 300,000 lines of code, because we said that the team size is big, hence the project size would also be big. Then the nature of the project as compared to the organic one, it is a medium sized project where the medium sized team is there, average previous experiences on the similar projects, and the team size that we have include both the experienced and the inexperienced developers. For example, utility systems like compilers, DBM, database systems, editors, etc. come into the semi-detached one. Innovation, if we talk about as compared to the organic mode, the innovation is medium, because when we talk about the compilers, database system, so we need to be updated with the recent technologies where the people could include more of the innovation into it. Deadline of the project again becomes medium, because and the development environment is medium, because some of the developers are either experienced or they are some of them are inexperienced, which reduces the development environment or the familiarity of the environment in which a particular software is being developed. It could be a utility system. Coming to the embedded one, here the typical size is above 300,000 LOC. That means we are working on the large projects, because here we have the complex interfaces like inclusion of the hardware as well. So the nature of the project, it is a large project where they are working on the real-time systems. They have complex interfaces, very little previous experiences. For example, there are ATMs, ATCs, the air traffic controls, etc., where the real-time update is very necessary, and hence the innovation needs to be done. That is the mandatory part. And because they are working on the real-time systems, the deadline of the project is very tight, because a delay in the project could lead to a very can harm the system. In the development environment, we have a complex hardware or the customer interface which is required, and hence the people needs to be very trained when they are working on the embedded softwares. These are the coefficients when we talk about the organic, semi-detached and the embedded mode. We have some of the variables like A, B, C and D, and we have some of the values. We'll look into it how to solve these kind of the questions based on the Cocomo model. So when we talk about the basic Cocomo, it gives an approximate estimates of the project parameters. It is given by the expression where we talk about the effort applied in person months, that is AB, multiplied by the thousands lines of code to the power B, and we have the D, that is the time that is required in months, that is C e to the power D. So E is the effort that is applied and D is the development time that is required in the months. When the effort and the development time is known, we can find out the average staff size to complete the project. That could be E by D, that is effort upon the time that is being required, development time basically. And when the project size is known, the productivity level may be calculated by the total lines of code upon the effort per month. That is, this is the formula, the lines of code upon effort. So that would be 1000 lines of code per month. So we have an example over here. We have the project size as 200,000 lines of code. So the lines of code would be 200 only, because KLOC we are considering as a single unit. Software development team has average experience. The project schedule is not very tight. So we need to calculate the effort, development time, staff size and productivity of the software. So when we are talking about this, the question says that it has the team has an average experience, and we have already seen in the semi-detached one that the team size is medium and they do not have very good experience. So here we are basically talking about the semi-detached systems. In the semi-detached systems, we have these coefficients where the value of A is 3, value of B is 1.12, value of C is 2.5 and the value of D is 0.35. So when we calculate these values, so the effort becomes, as we have seen over here, the value of the effort is A to the AB, A into the 200 lines of code to the power B. A is 3 and B is 1.12. So we'll substitute the values 3 into 200 lines of code to the power 1.12 and we get this value in per month, because we are calculating it in the person month. D is the time, the development time. Here we use the coefficient C and D. So if we look at the formula of D, that is C effort to the power D. So the value of C is 2.5 and the value of D is 0.35. We apply that value over here, we get 2.5 with the effort, that is 1133.12 to the power 0.35, and this we get the value as 29.3 person months. Similarly, the average staff size that we have just seen is E upon D persons, that is equal to 38.67 persons, which comes out to be approximately 39 persons. We again have an example where the project size is 400 lines of code and we need to calculate the effort and the development time for each of the modes. In case these three modes were not given, then we need to check the total lines of code, that is 400, and as per the question over here, the table over here, we typically see that there are 300 lines of code. In embedded system, we would only be calculating the embedded, but since here they are asking for the organic, semi-detached and the embedded ones, so we'll calculate the equations for the organic, semi-detached and the embedded one separately. So, the effort, as we have just seen, is A KLOC to the power B. In the organic mode, we get the effort with its value 2.4. The thousands lines of code is 400 to the power B. Calculate the values. For the development time, we have C, the lines of code to the power D, and this is how we will calculate the organic, semi-detached and the embedded mode values. Now, the next model that we have is the intermediate model. When we talk about the basic model, it allowed for a quick and the ref estimated, but it resulted in the lack of accuracy, because there we were only talking about the effort and the development time that was required in order to develop a software. So, Boehm introduced additional 15 predictors. Those were known as the cost drivers that we were talking about in the first definition, to take account of the software development environment as well. These cost drivers are used to adjust the normal cost of the project to the actual project environment, and hence increases the accuracy of the estimate. So, these cost drivers are divided into 4 categories. We have the product attributes, the hardware attributes, the personal attributes and the project attributes. If we talk about the product, it talks about the software reliability, the size and the complexity of the product. When we talk about the hardware, it talks about the runtime performance constraints, the memory constraints, the virtual machine that would be required and the turnaround time of the machine. Talking about the personal attributes, it comes related to the analyst part. So, analyst capability, the programmer's capability, how is the application experience, are they experienced or not, virtual machine experience, have they already worked upon such kind of projects, programming language experience, that is totally dependent upon the developer. Project attributes, the modern programming practices, use of the software tools, requirement development schedule, these all are the attributes that are used for the cost drivers. Then they have the multiplier values for the effort calculation. These are some of the cost drivers, and they have the ratings and different values for each and every attribute or the cost driver. This one was for the product attribute and the computer attribute, then the personal and the project attributes. Now, the coefficients, as we have just seen in the previous one as well, we had the values we have the coefficients for the organic, semi-detached and the embedded systems. Here also we have the same thing with the effort and the development time. In the effort, here we have the adjustment factor as well, because this adjustment factor comes with these cost drivers. So, we have a question where a new project where 400,000 lines of code embedded system has to be developed. They had a choice of hiring 2 pools. The first one is very highly capable with very experienced in the programming language, and the other one is the developers of low quality but lot of experience with the programming language. So, if we talk about the effort, because this is an embedded model, the effort would be A to the power B, that would be. So, that would be calculated. Now, EAF would be, we have the value, we have this as the formula where we have 1.14 to be multiplied by the factors over here. So, they talk about very highly experienced people. So, that is 0.82. So, we will be multiplying 1.14 with 0.82 to get the adjustment factor. This adjustment factor gets multiplied by the effort, and we get the value multiplied by this E, we get the value of the effort, and hence we calculate the development time with the formula C, the lines of code to the power D. The second one says that the developers are of low quality but with lot of experience in the programming language. So, we will multiply these two, the people with low quality and lot of experience with the programming language. So, if we look into the table here, people with low quality and for programming language, we have this high programming language. So, we multiply these two and we get this as the adjustment factor. We already calculated the E. On the basis of that E, we will multiply it with adjustment factor and we get this value, and hence we get the value of D. So, if we compare these two, here the development time is 33.9 months and here the development time is 36.9 months. So, the case 2 requires more of the effort and the time, and hence the low quality developers with lot of programming language experience could not match with the performance of highly capable developers with little experience. The next, we have a detailed Cocomo model which to construct the software estimate. It incorporates all the characteristics of the intermediate version with the assessment of the cost driver impact on each and every step of the software engineering process. So, it has 6 of the phases. The first one is the planning and the requirement, how the software needs to be developed. What would be the system design? Once the system design is done, then the architectural design is done in the detailed one. Then they talk about the code and the testing part, the module testing part, that is the unit testing. Then they slowly come to the integration and the system testing, and at the end they try to estimate the cost and the effort that would be required in order to develop that particular software. So, the effort is calculated as a function of the program size and the set of the cost drivers that are given according to each phase of the software life cycle. So, that is all for today. Thank you.